Hi students, in this video we will begin with the next module, module 5, link layer and physical layer. So as an introduction we shall review the services provided by the link layer. We have already studied all the services of all layers in the first module, but still we are reviewing the link layer services alone. Any device that runs in the link layer protocol is known as a node. Any devices means the devices like host machines, routers, switches, Wi-Fi access points, and all these can be think of as a node. The communication channels that connect adjacent nodes along a communication path is called link. So between nodes there may be wired links or wireless links. The layer 2 packet or the PDU at the layer 2 is known as frame, and the main service provided by the link layer is framing. Means it encapsulates the datagram into a frame and transmits the frame into the wired or wireless link. We shall divide the link layer into two different sublayers. One is data link control layer and another is multiple access layer or multiple access resolution. Uh, the link layer is data link control layer is performing the services like framing, providing reliability, and some services, main services are provided by the data link control. Whereas the multiple access resolution, the second part of the link layer, which is only dedicated for accessing the shared channel. We will study the two different layers in detail in the coming slides. Then first service of the link layer is framing. As we referred in the previous slide, what is framing is it is packing of a set of bits. There may be two different types of framing. One is character oriented framing and bit oriented framing. Framing in the data link layer encapsulate the datagram into frame before transmitting over the link. It creates frame by adding header and trailer. Listen carefully here that trailer is added in the link layer and no other layer is having trailer, but all other layers are adding headers. And we will see what is trailer, what is the content of the trailer in upcoming slides. The frames are distinguishable from one another. That is, one frame must be separated from the other frame because the frames may be fixed length or variable length. So we need to put some identification flags in between two frames. So in the figure shown here, we can see that two different flags are here. Flag at the beginning of the frame as well as flag at the end of the frame. So this will help to identify the beginning of the next frame as well as end of the another frame. Then header is added and trailer is added along with the data. So the portion up to here, this slot is the variable length data or the packets, and the header include source and destination address. We will study in detail what is this header information. And the trailer information is usually carrying the CRC bits or error detection and correction bits. And the flags are usually 8-bit specific pattern, that is decided by the sender and the receiver on prior agreement. Common flag will be used in the receiving side and the sending side. Then, as I said in the previous slide, there are two different types of framing. One is character oriented, another is bit oriented framing. So the main activity of framing is adding the header and the trailer, or adding the flag. So in character oriented, there we are putting the flags, and the flags are special characters. Whereas in bit oriented framing, special bit patterns are used as flags. In bit oriented framing, data section of the frame is a sequence of bits to be interpreted by upper layer as text, graphic, video, and so on. Actually, in the previous case, in the character oriented framing, there it is normally suggested for character type of data. So special characters indicate as flags. Whereas in bit oriented, usually it is used for transmitting data like text, graphics, and video, that is a continuous stream of data. So we use delimiters to separate one frame from another frame. And for this, we are using 8-bit pattern flags as delimiters. If the flag pattern appears as a part of the data, then special technique called bit stuffing is used. That is, suppose we are using this as the flag. This is a normal example of a flag, beginning and end with 0, and the remaining 6 bits out of the 8 bits will be 1. Suppose the same flag is coming as a part of the data, then we use bit stuffing. That is, bit stuffing is a process of adding one extra 0 whenever the 5 consecutive ones follow a 0. Suppose 5 consecutive ones are appearing, then additional 1 0 will be added in order to tell the receiver that this is a flag. If this special bit 0 is not added, not stuffed, then there won't be any data of the flag character. So we are concluding here with two different types of framing. One is character oriented, another is bit oriented. Character oriented is used in character type of data, and bit oriented is used for text, graphic, and video type of data. In character type, we use special characters as delimiters, whereas in bit oriented framing, we use special bit patterns as flags. Then next link layer service is link access or multiple access. This is being performed by the lower part of the link layer. As in the previous slide, as in the second slide explains, there are two sublayers for the link layer. The second half of the link layer, multiple access layer, it is performing the activity of link access. This we need to study in detail in the same module in the coming classes. So MAC layer specifies the rule for accessing the channel, and usually a common shared medium will be there. As you know, the medium may be either wired medium or the wireless medium. Whatever it may be, the medium will be shared by multiple devices. So which of the node or which of the device is accessing the channel? If multiple nodes trying to access the same channel at the same moment, there will be some problem of accessing the channel. So this is what the issue of multiple access. So various protocols are defined for solving the problem of multiple access. Then another duty of multiple access layer is MAC addresses are added to the frame headers to identify the source and the destination. Here you notice that MAC address is different from IP address. What is MAC address is? It is a 48-bit address that is defined in the hardware itself. But the IP address is a logical address and MAC address is hardware dependent and IP address is dynamic. MAC address is static. Then next activity of the link layer is reliable delivery between adjacent nodes. We have studied in detail in the third module, that is transport layer is taking the main responsibility of reliable data transfer RDTs. But the same thing is repeated in the link layer also, but it is between adjacent nodes. In case of TCP and UDP, there the reliability is provided between source and destination. But here it is between adjacent nodes. And the reliability service is mainly used in case of wireless channel. That is, wireless channel are more prone to error. High error rate will be there for wireless channel. That's why the reliability concept is implemented in the link layer, and this is mainly used in the wireless medium and seldom used on link channels like fiber optics and twisted pair. They are less prone to errors, whereas wireless channels are highly prone to errors. Then next service provided by the link layer is error detection and correction. The bit errors may be caused by the signal attenuation or noise. We know that the physical layer is using hardware channels, wired or wireless channels for the communication, and there is a chance of error because the channel is not reliable. And the data is moving in form of signals. So the attenuation happening to the signal or deterioration of the signal strength when moving towards the destination or when the distance is increasing, the signal strength will be reducing. This is called a signal attenuation. So bit errors may cause because of the signal attenuation, or some noise may enter into the channel. These two are the factors which cause the bit errors. So error detection and error correction must be performed in the link layer. Error detection in the link layer is more sophisticated and implemented in the hardware. We studied the error detection and correction techniques in the transport layer. There we use the checksum, and it is in the upper layer. The same activity is repeated in the lower layer also. Two types of single bit errors. Two types of errors are there. One is single bit error, another is burst errors. Single bit error means in a set of data, one single bit may cause errors, whereas in burst errors, a continuous sequence of bits are altered. Then the receiver has to identify the error and correct it before delivering into the upper layer. So the correction technique used is the retransmission. Here we can see the two types of errors. One is single bit error. The data from the source in this position is at a 0, but it is received as 1 in the destination. So this is known as single bit error. In case of burst errors, a set of data is getting altered. Here, this is the receiving side and this is the sending side. Sender sent 0 and receiver received it as 1. Here also the sender is sending 0 but the receiver is receiving it as 1. Again, in this position it is sending 0, it is receiving 1, and in this position also it is receiving 1. So when comparing the sending side and the receiving side, a set of bits are altered. So the starting point till the end point of the bit errors together is considered as the errors, and they are burst errors. And now the link layer is actually implemented in the hardware side. As in the first classes we studied, the link layer is mostly associated with the hardware level. So you are familiar with this type of cards in your computers. They are known as NIC cards or network interface cards or LAN cards. Okay. Through this LAN card, there will be a port. Through this port, we are attaching the hardware channels or cables into your host devices. And Ethernet is using 802.3 and wireless is using 802.11. These are the common standards used in the hardware level, and actually the addresses are processed and configured at the NIC card. This is the end point of the link layer. This is just to show you where is the position of the NIC card in the sender and the receiver. This is the end point at the sending side and the end point at the receiving side. So the link layer is attached as the hardware to the host devices.